Hello, my name is John Aid. I am a solution consultant for Bricsys in North America. I'm a registered architect and I'm excited to present to you Scan to BIM for surveyors. My presentation will introduce you to the flexibility BricsCAD BIM provides for importing point cloud data and modeling tools for converting point clouds into BIM models. We begin with the point cloud. Once a project is scanned, the point cloud can be shared in many common formats that BricsCAD can import. Receiving individual scan files is especially helpful for the interior spaces first modeling method. No extra software is required to bring a point cloud into a BricsCAD BIM drawing file. Once inserted, you are ready to model, and the point cloud can be manipulated for better viewing and modeling. We'll see two modeling workflows for converting the point cloud into a BIM model. The first workflow uses an AI-based tool for automatically recognizing the surfaces in an enclosed room and accurately converting them into a solid representing the space. With these solids, we'll then use another AI tool to automatically convert the space solids to walls, floors, and ceilings. Our second workflow will utilize intelligent direct modeling tools purpose-built for rapidly tracing a point cloud with walls, floors, and solids. Next, no matter which method is chosen to create the base architecture, we can easily add doors, windows, and other components. With our project modeled, we can share the information using IFC export. The Spaces First modeling method will work well for scans more current or modern architecture with simple, clear rooms, while the direct modeling method would work well with older historical buildings with complex geometry. Based on your project, you may use a combination of modeling techniques. Now let's see the Scan to BIM workflows in BricsCAD. Let's begin our BricsCAD Scan to BIM workflow by attaching a point cloud into our design file. We attach a new or previously processed point cloud from the Point Cloud Reference Manager. When we attach a point cloud to a DWG in BricsCAD BIM the first time, it is pre-processed. Pre-processing optimizes the point cloud, prioritizing those points that are most relevant. We can choose to import one file or a folder containing multiple scans. BricsCAD supports multiple scan file types, including E57, HSPC, LAS, PTS, RCP, to name a few. A point cloud with multiple scans is preferred for Scan to BIM. The scan data will be converted to a BricsCAD data structure and is saved in the point cloud cache folder. This pre-processing is a background process and multi-threaded, meaning you can work in the same or other drawings while waiting for the point cloud to finish pre-processing. Before an HSPC file is exported, the interior and exterior points can be classified using Leica's Cyclone 3DR software. The HSPC format, or Hexagon Smart Point Cloud, handles large amounts of scan data better and faster. In this short video, we see a site scan where points are auto-classified initially and other points classified manually. Classified points provide more granular control of what points are displayed and exported based on logical groupings. For example, the mechanical equipment is classified. It and other points can then be turned off if only site points are needed for a digital terrain model. From the Point Cloud Reference Manager, we will insert a pre-processed HSPC point cloud. As you can see, a pre-processed point cloud inserts in seconds and is ready to use. The new Point Cloud Manager panel lists the new point cloud and organizes scans, regions, and classes of points. I can open up an individual scan in the bubble viewer and pan around the scan. I can look at a specific region of the points, and I can create new regions, and I can further isolate what classes of points I look in the region, whether by wall, by ceiling, by floor, or a combination of classes. If you have access to the HSPC format, then you will be able to use it immediately in BricsCAD. But remember, we do accept other common formats too. Once we insert a point cloud into our file, we typically want to view it using a section of some sort. We have our default section tools where we can create sections in different orientations to the point cloud. But we also have a tool specific to point clouds that will create or detect our floors in the point cloud and create a section volume for it. I'm going to go ahead and use that tool, but I'm going to change my orientation first, so we can see it at an elevation. We'll go ahead and detect our floors. We'll go ahead and use a full scan of the point cloud. And immediately, if you saw that, we now have a section object here. If I select it, we can zoom in and you'll see that there is a target. And there's also some text here, but it's off to the side. Identify this section object. Fortunately, in the properties, we can change where that target appears or that callout. And we'll go ahead and change it to the start position. Start position is over here on the right, and it's obscured, but it also has a tag. Let's go ahead and enable the section. And have it clip the point cloud. Point clouds are typically aligned in space based on real-world coordinates and do not typically align orthogonally with our current UCS the minute we bring them in. The point cloud can be repositioned using regular move, copy, and rotate commands. However, we can easily align our point cloud in BricsCAD to the UCS using our point cloud align tool. I'll zoom in a little closer, and we can see that we have points that look like they're representing the vertical surfaces and walls inside our plan. Using the Align tool, we can pick where those point cloud points align vertically, and it will reorient the point cloud for us, as it's done here. We'll just move our section to get it aligned with the point cloud again. And now we can see that, in fact, our point cloud has been aligned horizontally. Perfect. Now, when a point cloud includes more points than are needed, we can easily craft the point cloud to show just what is needed. And we want to choose the points inside the crown. Fortunately, cropping does not permanently delete points, so that the points cropped can be redisplayed later, and that can easily be done by just toggling the display of the points off and on the ribbon. Now that we've prepared our point cloud, we're actually ready to start using it. So our first modeling workflow works with tools that allow us to select the surfaces inside a room, and it will stitch them together into a solid representing the space volume. Well, how do we do that? If you'll notice these green spheres, they represent an individual scan station. And in BricsCAD, we can actually leverage those to start modeling. We'll start in this room here. To access one of these bubble views or scan positions, we just double click on the sphere. It opens up a view that we can move and resize, and then we can just pick and pan around inside the view to see all that the scan has captured. Now we can actually move and work inside of this bubble view. So we're going to use our Point Cloud Fit Planner tool to start detecting the surfaces in this room. Once I've selected all the surfaces, on the Point Cloud Fit Planner panel, I can accept them and look in the view beyond. When I do that, it has now generated a solid of that lane. Now, while in the command, I can now move to another bubble view and start the process over again without exiting the command. I do that by switching bubbles. Now, in this room, I can't see all the walls. But what I'll do is I'll select the walls I can see first. And then for the walls that I cannot see, I'll go ahead and switch bubbles again. Want this bubble over here by the doorway. So I'm going to pick it. My bubble view changes, change my orientation, and now I can pick the last remaining surfaces. And again, if we look to the side here, I'll select accept, and it creates a solid for that room too. So moving from bubble to bubble and working within the bubble is much easier to navigate than trying to cut multiple sections to view different surfaces inside of a room. And the only way those points were captured is through multiple scan positions. So we do want a point cloud that has all those scan positions available to us. When I'm through, I can cancel out of the command. Jumping ahead, we have the ability to generate solids for almost every space on our floor plan, except for one. The one space that was missing was the stair, because the stair went up through multiple floors and we only have scan information for one floor. So this particular space we have to estimate and create our own solid. So I've already traced a polyline And all I need to do is create a solid by extruding it. Now I have all the solids I need to move forward. Again, these solids represent the spaces of all the rooms on this particular floor in the building. I'm only working with one floor. Now, because these were defined based on a point cloud, the wall surfaces and the horizontal surfaces may not be perfectly flat or perfectly vertical or even parallel where two faces face each other on either side of a wall. So we need to optimize or clean up these solids before we can go to the next step. Our optimize command will automatically recognize the solids in our file and select them for us. And we have some choices on the optimize panel as to some angle tolerances, what we want to include when it's going to process it. I'll zoom in a little closer and we can preview before we commit to it. You should be able to see some of these surfaces move as they're aligning and straightening just in the preview. Sure enough, I saw some surfaces moving when we optimized them, and I'll go ahead and accept that. Now our 3D solids are optimized. Next, we can use BIM invert spaces. This AI-based command creates a building from a set of 3D solids by fitting slabs and walls around and in between them. In seconds, we now have a model with walls, a floor, and slabs representing the ceilings at different elevations. Here we see the inner walls. Using Structure Browser, we can isolate the slabs to inspect them. Likewise, we can isolate the walls to inspect them as well. We now have a BIM model ready to add more detail, starting with doors and windows. So we've gotten the base model to a point using our first method. Now we're going to go on to a second method. So going back a few steps, we're going to where we have the point cloud brought in, we've cropped it, we've aligned it, and we've got a section through it, or we've detected a floor which created the section. Now I want to use some smart modeling tools to help lay out walls and floors very quickly. We'll start with using our Quick Draw tool. So Quick Draw tool has been a BricsCAD tool for at least a couple of releases so far. This allows us to quickly place walls and a floor slab with toothpicks. And obviously I can define the floor to floor distance, the width of the walls, and the slab thickness. This tool also works on 2D line work. So if you're converting 2D line work to 3D geometry, like you have a floor plan that was done CAD before BIM, you can literally trace it and converting to BIM very rapidly. This works very well tracing on point clouds as well. Next, we have a tool that is new in version 23 that allows us to quickly add these interior walls between these walls we just created with Quick Draw. I can reorient the walls. Hopefully you can see where my cursor is. And with a quick tap on the control key, I can switch its orientation from horizontal to vertical, and I can change the thickness of the wall that I'm going to create. And we'll start by placing the walls that are running vertically past the stairs. And then we'll put another wall here. And we'll come back and look at what to do because it changes thickness. And then I want to place a horizontal wall for the corridor. Again, I'll change my orientation and the wall thickness. These tools really do make modeling and top of the point cloud very fast. And again, I'll add one more vertical wall. Now, I have a couple of conditions that I want to address. First, I really need this wall to change thickness when it gets on the lower side of the corridor wall. In version 23, we've now extended the capability of some of our modify commands to 3D solids. So now I can use trim command to trim solids, and it will trim it back to that corridor wall. Now I can use my quick wall tool again to place the wall. That's a little bit thicker. Now, what about this wall here that makes a couple of bends? I could construct them in the same way and do a bunch of edits, but it might be faster to just lay them out using another modeling tool called planar solid. With this, we can define the width that we're going to place and what the height of it is. And then we can simply start tracing our wall. Notice it has a justification about center, but I can quickly tab to the different justifications as I'm laying it out. Now we'll take a look at the walls and floors that we've just created. So again, we'll jump forward where we've actually created the remaining interior walls. So we can see that very quickly by turning off the display of the point cloud. But we want to leverage the point cloud to help position our walls and figure out what size they are before we place them. So I'm going to go ahead and turn the point cloud back on. We'll go to a view here so we can actually look and see the full height of the door. So we can pick a couple points to get the distance for the width and the height of the door, which I've already done. We can go to our top view and we can actually change our mode from just a simple top view to something called top view mode. So over here, I have a 4-0 target, and when I activate it, it will do a thinner slice through the model in a top-down orientation. I can still orient my view to some other orientation as needed. But we'll go ahead and work in a top view. And with our geometry, if we have trouble looking at the point cloud through it, we can also select all our building elements and change their transparency. I like to do that whether I'm using top mode or not. It just means that I can now see the point clouds more readily through the solid geometry. And this is just a temporary setting. It's easy to switch that back. Now I want to place a door in plan. And from our library, I can go ahead and navigate to our doors. Select a single swing door. I know that the width of this door is 864 millimeters, and the height of the door is going to be 2080 millimeters. And because I can see the points readily through my transparent geometry, it makes it very easy to place the door accurately. And of course, after I place it, I can change the hinge side very quickly on my quad. And I can place another one of the same doors again from the quad using BIM insert. This will place the same door with the same dimensions so I don't have to input them again. If I have many of the doors, using the BIM insert command really speeds up the operation. So now I want to go to an elevation view and place a couple windows. Let's turn off our section plane so we can see more of the elevation. Get a little bit closer. Again, I've already done takeoff, and these are 2200 millimeters wide and 2080 millimeters tall. So from my Windows library, we have a double hung or a 1x2 window. And I can put in the correct dimensions. And I can even use my dynamic input to precisely position it at the sill height or from an adjacent object. We'll go ahead and place to insert the window once. And similar to the door, I can also use BIM insert to place another window the exact same size. If I'm placing a lot of the same window, if I place it once, I can also just use the manipulator. To copy it further down. Or we can take a look at our model with some of the doors and windows we've just placed. So again, very quickly I was able to generate a base floor plan and start adding interior walls. Continuing to do that wouldn't have taken me much longer to get to this point and then start placing my doors and windows. And again, if I jump ahead, you can see a plan that has most of the doors and windows already placed in it. We're now at a point where if we need to share this with somebody who maybe doesn't use DWGs directly, but does have the ability to use an IFC, we can export this model out to an IFC. Exporting to IFC is very quick and easy. We also have some settings to look at before we do export it. So again, we can enter settings and search for IFC export. IFC export has some settings here. We also have the ability to define a mapping table, meaning if we want certain category of elements to be mapped to different categories than the IFC standard, you can create a simple file that either overrides the category that it's mapped to or prevents it from being mapped altogether. When we're ready, we select IFC export. Again, down on the command line, we'll do the entire model and pick a place to save on export. I'll just overwrite what I have. And once our file's exported, if you want to check it for integrity, you can open up the file in an IFC viewer like Solibri Editor and move around the model and select elements and get information off of them. So this is the end of the demonstration for Scan to BIM or Surveyors workflow. We've seen how easy it is to bring a point cloud into BricsCAD and manipulate it in terms of viewing it, aligning it, cropping it, and then a couple methods for modeling walls and floors and ceilings. One method is converting the surfaces into solids that represent the spaces. And then the second method is more of a direct modeling workflow, but instead of just modeling directly, we're actually using some smart BricsCAD tools like Quick Draw and Quick Wall to quickly lay out the majority of our geometry, and then even using simple manipulation tools like trimming solid that we've introduced in version 23 really helps speed up the process. This concludes the demonstration of the Scan to BIM workflow using BricsCAD BIM. To summarize, we started with point cloud scans saved in a common format that BricsCAD BIM accepts. We saw how easy and fast it is to process, insert, and manipulate the cached point cloud. Two methods for modeling from the point cloud were reviewed. With the base architecture modeled, we saw how easy it is to add doors and windows. As a final step in our workflow, we saw how we can export to an IFC file. My hope is you learned something new about the power of BricsCAD BIM and its ability to incorporate point cloud data into your project workflow for modeling existing conditions from point cloud scans. My colleagues have authored these additional sessions on detailed design and documentation, bill of materials, and typed plans using BricsCAD BIM that you will want to see. Thank you for watching Scan to BIM using BricsCAD BIM.